Hi, hello, good afternoon. I think we will continue the introduction. So for the first part of this afternoon, we will talk about the hardware config. I think hardware config is a very important feature for AS and the H PLC. Okay. Here use an example to show you. Actually, we can use the hardware config to do the system layout of a PLC. And again, just remind you that for DVP PLC, we don't have the hardware config function. So this one is only available for either AS or H. Okay, so this example will show you that we use the CanOpen remote I/O. Okay, so basically this is the main PLC, and you can see this is for AS 218. Oh, sorry, 228. Then so you can find here is for So for this one, we use the built-in CanOpen function card. So that's the reason you can see here we did not find any CanOpen function card from 1 to 5, and from 6 you will see this one is for the remote module SCM, and then we add on the SCM CanOpen function card. So you can see like this. Okay, so this is the hardware config basic function for layout. So after that, we can also use this layout to get the BOM from hardware config. And here we can also use the same, we have a same function in the DI designer. This one is based on ISP SOP, so you can see this is the hardware config. Then in DI designer, it's actually also hardware config, but the name will become hardware configuration. Okay, but you can see exactly same function as ISP SOP. Okay, so you can also get the BOM of this system architecture after you finish the layout. And okay, and this is what I mentioned in the morning section. For the extension I/O, actually you can change this one. Example for the default, it definitely start from 0, right? But I mean for the extension I/O, you can change this one either to 2.0 or 10.0 or 100.0. So this one is up to your system arrangement. Okay. And here is talk about how to add on the function card. So as I mentioned in the morning, for AS300 PLC, we have 2 function card slots. First one, if you click, then you'll find only limited, like mobile serial and the analog function card available in slot 1. Later I can also show you, but if you click slot 2, then you will see more. Actually, if you click like this, and if you click use the SCM module, then you will see only this limited. Only for the built-in AS300, then you can use this. Okay, so there is some difference between the built-in slots and if you use the SCM module and add the function card. Okay, and this page is talking about the hardware config, especially for the serial and the mobile TCP IP setting. Okay, on the top will be AS and the H PLC. So inside the hardware config, you can find easily that when we go to the system, then we'll find the system setting and the serial port setting, and even for the Ethernet port setting. So example here, we use the 9600 7E1 ASCII format. We just do the setting inside hardware config and change the IP also inside hardware config. This is for AS and H. But what we have to do in DVP, this one maybe some of you already know, but some maybe see this for the first time. This one is actually same as what we did in from the Delta PLC DVP PLC user manual. You might see some data register like D1122 or 1121 and like M1143, etc. So actually, Delta also provide this kind of function block. So you can just simply click this one. Example, this one, if you don't know the meaning, you just move your mouse here, so it will show you the first one is baud rate, then one is 9600, and then data length is 7 or 8, then parity check is even, not, or odd. Then start bit is 1 bit or 2 bit, ASCII or RTU mode, then station address, etc. Okay. So in ACE, we just do the configuration inside hardware config, but in DVP, we have to declare or define this one by one. So this tool is exactly the same function. Okay, and in DVP PLC, if we want to modify the PLC IP address, we can use either DCI soft. I think most people know about this. So example, this now the IP address is 192.168.1.7, and if we want to change file, we have to use DCI soft to modify. But in ACE or H, we just simply change from here. Okay, so that's the main difference between different series PLC. Not sure, do you have any question regarding this part? Okay, if not, then we continue. And by the way, for DVP, we can also use the IEX blower. But to be honest, I know very limited customers know about this software. Okay, and next will be the data exchange function inside hardware config. Okay, so you can see for the data exchange function, basically, for Delta AS PLC, we will offer 2 serial port, COM1, COM2, and the Ethernet. So you can see here, we can support not only Delta PLC or Delta device. As long as it's a standard Modbus device, then we can use the data exchange function to pull the data from third-party Modbus device. So you can see this one is the update cycle. So basically, the default is 15 milliseconds. Then you have to set the timeout. But I have to say, for some device, example like maybe a power meter or some sensor, if you want to pull the data, basically you might consider to increase the value, because sometimes their communications cycle is not that short. So this one just want to remind you, sometimes if you use use the default value, sometimes you may encounter communication fail or error. So just remind you, if you encounter this, can try to increase the value. And then here is a Modbus function code 17, or you convert to decimal will be 23. This one, if you want to use this, that means one command, Modbus command, you will read the data and write the data at the same time. But this one also remind you, have to check whether third-party device or the device you connect it support mobile function code 17 or 23 in decimal. Okay. If not supported, if you use this function code, then we'll get a communication error as well. Okay, and then is the data address that you want to map. Example, we read the standard mobile address 1000, and then this data will map to D4000, data register 4000 in ASPLC, and it will move 100 consecutive words. So if you see this arrow, that means from external device to local device. And if you see this, that means the data will write from ASPLC local device to external device, and the maximum also 100 words. But to be honest, this one you can modify by yourself. Okay, next is for the module check. So in DVP PLC, I think here is a function that maybe most people never know this function before. So as I mentioned, in DVP PLC, we don't have a hardware config, but once you find the PLC, and then you can check the connection information. So you can also achieve the similar function in DVP. Okay, so as you know, for DVP, we have only 12 and 26 SE. So it means it's not possible for standard PLC to reach 40 points. So that means we actually have some module connect with SE. And then this is the example that we config under hardware config. Then we switch to online mode. And after that, we can check the module state. Okay, maybe I can show you. Again, most important is here. You have to select the correct interface. I think in the morning I already showed you that we connect with SE, right? And AS228. Okay, so just double click this one, and then you can check the I/O module status. And if you have a connect analog input and output module, then it will also show here. So this is another similar function for DVP PLC hardware config function, but to be honest, you cannot find any hardware config here. But just let you know, you can achieve, you can check the I/O status by this way. Okay, then I open another project. Okay, always remember this is the first step, but because as you can see here, already select. Then we can check the PLC status again. And after that, we can double click to enter hardware config. So you can use either scan to check the device status. Okay, so then you can find we have connect one more module to the ASPLC, then we can switch to online mode. So you can also use hardware config to force on without do any program. Okay, so this is the function for hardware config module status check. And next function, I think will also very helpful, especially you try to integrate it with a third-party device. Okay, so you can see inside the hardware config, we have the tool, right? So you can find the device description file manager. And after you click this one, will pop out this window. Then you can click this one, install description file. So I believe most of you ever heard about the EDS because in device net, CANopen, or Ethernet IP, all this kind of description file we call EDS. And you may wonder what is IODD. IODD is for IO-Link. And then maybe some of you already have some experience with EtherCAT. So for EtherCAT device, we will have so-called ESI. Okay, so that is the most common one. I think should be EDS. And in the morning, I also talk about IO-Link. So if you try to connect a third-party IO-Link, maybe sensor or device to Delta IO-Link master, so you have to install the IO-Link information. Sorry, the description file, IODD. Okay, so here you can see example, we use the IODD. So this example, the IODD, we use the Allen Bradley 45 CRM. And you can see the file name extension is actually an XML file. Okay. And then once we select and import, so you will find here, I will show the manufacturer name and some basic information over here. And if you want to use the EDS file, like you want to control the Ethernet IP, then you can just import the EDS maybe from Kians, from Omron, etc. Then you can also get this information, then go to do the data mapping. Not sure any question regarding this page. Okay, I'll show you under tool, then device description file. Then you can select the install description file. So example, this is for the IODD. So you can see we have so many different brands like Allen Bradley, Maloof, Kians, Omron, Panasonic, or SIG. Yeah, and then example, we use the Panasonic. So once this done, then you will show this kind of information. Okay, so that's roughly if you want to import third-party description file, we will operate like this. And next is this page will show you how to configure the Ethernet IP data mapping. This one is actually you can consider same as the data exchange function we just I just mentioned in previous 2 page. So here you can see we also can import a third-party device. Example, this one is for Kian's region system CVX400 series. So we use the file description manager to import this file, and after that we can do the data exchange configuration. Okay, so here you can see on this network we have several devices like one ASPOC. We have 3 ASPOC. So definitely the first one is the master, and then this is the adapter device we connect. Okay, so like this Kian's CV device or Delta MS 300 inverter. So you can see for different devices, the length, the data length, or we can say the data exchange of bytes is different. Just want to remind you that for Ethernet IP, the basic unit is bytes. So in the last 2 pages, we mentioned is 100 is based on word, so the unit is different. Okay, so you can see for Delta PLC itself, would be 200 bytes. That means it will be 100 word. So basically, it means the same thing. Not sure any question regarding this page. Okay, and I think compared with other competitor, our data exchange function is quite, no matter it's based on mobile TCP or Ethernet IP, this function is quite convenient, because if you ever use Omron's Ethernet IP, you have to configure a lot of step, and also need to do some coding. But if you use our Ethernet IP, we just do the mapping, then we can pull the data automatically. So it's quite easy and convenient. Okay, then this page will show you the field bus, especially for mobile TCP and Ethernet IP. So I make a comparison table that basically for all the Delta device that we support standard mobile TCP. This is for sure. But as you know, for Delta, the first generation DVP, most of the device we actually don't support Ethernet IP. Okay. And for the Ethernet IP, basically, for Ethernet IP, we have two different type. First one is the explicit, another is implicit. So I don't know how to describe this, but if you have the concept of PDO or SDO from either DeviceNet or CanOpen, then you can consider explicit like SDO, then implicit like SDO. So that means implicit information you can pull the data very frequently, but SDO, that means every time if you want to get the data, you have to send out the command. So this one, basically, you can also consider this is for more like a device important information that might affect this device drop or something else. Okay, so the explicit normally the speed would be much lower. So you can see the typical use like here, you'll be a diagnostic event. But if you want to get the real-time data, then we'll use the implicit. Okay, so you can see for Delta A PLC Ethernet type, like a DVP function card, EN01, this one basically doesn't support. And for the SE series or ES2-E, ES3, and for the new generation, it all support. Okay, and then come to the Ethernet IP scanner. Ethernet IP scanner, if you imagine that just similar to the Modbus serial master. Okay, so you can consider this as a master. So for master, now we have only ES3 because this one is use the same CPU as ACE. Then in the morning also talk about these two, also the new generation. So it support Ethernet IP scanner. Okay, then for like this device, we can call this one adapter. So for the adapter, most of the series also can support, but here I just want to emphasize about the 12SE. I believe maybe some or most of you don't know that Delta already released the new version of 12SE. So basically, you can tell the difference from their firmware version. If you see the firmware version is V2 point something, then this means the new firmware, also new hardware. Then you will support Ethernet IP adapter. But if you see the firmware version is a 1.90 something, then that means this is all hardware, so it cannot support Ethernet IP adapter function. Okay, regarding this page, not sure, any question? Okay, if no, then we move on. Okay, and this is a field bus for another protocol. So you can see for H redundant PLC, basically we don't support CANopen, DeviceNet, Profibus, DP master slave, or even Profinet slave. Okay, so you can see like ACE or PLC will support CANopen, DeviceNet, and Profinet slave. So here you can find that actually most of our solution is not really a very complete solution, because like H series we don't have the Profinet, but AS series we don't have the Profibus. Okay, anyway, this one just let you know our what we have for different series of PLC. Okay, and here we'll show you the data exchange advantage. I think this one, maybe some of you ever used before. In DVP PLC, we have one function called PLC link, but PLC link eventually is based on the function data exchange. So that's why in the new generation like ACE PLC or H PLC, we always we will say this is a data exchange. We will not use the PLC link anymore because that would be more consistent for user to understand. Okay, here you can see for the different device, we might use the different software to do that. So in DBP PLC IS485, we have to use the network config. But definitely, some of you might say we can use the standard way, just move to specific data register. But that one is very difficult and troublesome, especially for the new engineer. So I won't recommend that way. So if you still have some project that you use the DBP PLC, and you can consider use the network config to do this. Okay, and like DBP EN01 SE, you can do the data exchange inside DCI SOAP, and also for the ES2-E. And then you can see most of the new device, we can do the data exchange function under hardware config. And some, if you still remember, because we just have some PLC can work as Ethernet IP scanner or master. So only in this model can use Ethernet EIP builder to collect the data. Okay, and here is some summary that the DBP PLC built in IS485 can support PLC link up to 16 or 32 slab. This one is up to the model, like SA2 would be, or we can say the general mention second generation PLC would be 16. And like SV2, EH3, we have 32. Okay, and this one already mentioned, as long as it's the standard Modbus, even for third-party device, we can use our data exchange function to pull the data from them. Okay, and this one is when sometimes you want to connect with the Mitsubishi PLC for EN01, this support MailSec protocol. Okay. And this one I won't go too detail because all are repeat the same content. So just the unit is bytes. Okay. So you can do the data exchange function inside. And then this one is for the Modbus TCP and the serial. Okay, so you can see the remote device type can be standard Modbus or other DBP, ASH PLC, and the new one is for also a Delta robot. That means if you use the SCARA robot or articulated robot, you can also use the a data exchange function. But if you use a Delta robot, then just remind you the data exchange update cycle or timeout, please increase this value. This is very important. Then for H, TCP, and serial data exchange function, I think almost same as AS series. Then this one is for DBP. And one more thing, just want to highlight that the enable condition we have three. One is always enable, another is a PLC on, and the third one would be the program. So just up to your application, but I think user always enable will be the most easier one. Okay, and this one is what we mentioned for the DBP PLC. You can see here we have so-called network config. So you can also draw the system diagram. I mean, maybe example 2 device. Then after that, you can do the data mapping like this. Okay, not sure. Do you have any question regarding the hardware config? Okay, if not, then we move to the symbol and create the function block. Okay, in the morning we have mentioned the profile of the software. So we have several methods to add on a symbol. So you can just double click in this area, or you click this one and add a symbol. Or you can just write the program and define. Or you can import the local symbol from another file. So I will show you how to do this. Okay, so basically we create a new POU, and this portion already mentioned in the morning. If you did not select active, that means when you download a program, even the condition is fulfilled, then the program will not run. Means no output. Okay, so how to create a symbol? So you can see we can just double click. Okay, you can just select here. Sorry, BCD is a reservoir, I forgot. So for example, we use the BCDE. So you will auto assign us the board device, and then example we output. Sometimes if you encounter this error, you might save the program. And if you even after you save the program, but still pump out this error, then the only way is close and create a new one. Okay, so anyway, just let you know, you can create the symbol based on this. And here is based on DI Designer. So I think similar way you can, but in DI Designer you can use the double click. Okay, so you can define when you write a program or import from the CSV file or add the symbol. Next is to check the symbol class. Okay. So basically for the symbol, we will have global and local. So for global symbols, we have only two types, standard variable and variable with retain. Retain means when you power off and power on, you will remain. You can consider the value will keep. Example, if we define a data register with a variable retain, then before power off we give the value 100, and after you power recycle and check this data register, it still remain 100. So this is what we mentioned, the variable retain. And then for the local symbols, you will see local symbols we will separate with two parts. First one is for the program or POU. So for the program, we also can define only standard variable and variable with retain. And second part would be the function block. Okay, so for function block, we will have much more. So function block, you can see we have the standard variable, variable for input, variable for output, and variable for in-out. Okay, so remember this is only defined for a function block. For the standard one program, we support only a variable and the variable with return. Any question? Okay, and this is based on the ISP, and this one is based on DI Designer. Okay. Okay, and this page show you for the different series of PLC. We also have the different type symbols. So you can see because HPLC is our high level PLC, so you can see the data type will be the more than other series. So like DBP, we have both. We have all Boolean device, word device, double word, real, timer, counter. But here you can see we have also string and integer, double integer, etc. But H with more like a double word, long integer, long real. Okay. So different PLC, the symbol type would be slightly different. Okay, and this page just show you the symbol naming restriction for identifier. So first one is you cannot use to underline at the beginning. Okay. Second is you cannot use underline as the ending. Okay, and then for the symbol name, you cannot duplicate with the device or data. So for example, you cannot use M1 or D0 as the identifier. Just like I just show you, I use the BCD because BCD is a command, so it will show error. Then the symbol name cannot repeat in the local symbol, but you can define the same symbol name on global and local. Then symbol name, the length should be within 30 characters. So like this one from A to Z, then we can add on another 4. Then total 30. Okay, and empty or space identifier is not allowed. And then you must select the data type, otherwise it will show error. And here is for the address for some variable. Okay, let's say if you try to you will export the symbol and connect with Delta HMI. At this situation, you must define the address. For other scenario, basically no need to assign the address, but if you want to export the symbol or export the variable and then import to Delta, either DOP solve or DIA screen, then you must define the address. Okay, this is very important. And then here just example, if you try to modify the sequence of identifier. So here we use the function block as the example. So we define four 4 input and 2 output. And we want to adjust the sequence, so you can see we just use the auto plus up and down. And example, we change like this one, so you will see the sequence in function block will also change, modify. And this one is for the simple filter. For simple filter is example, if we use a lot of input, for example, and you try to find out all the input, so you just use the input with the star, then you will filter out all the input information. Okay, then here I will give an example how to create a function block. So you can see here, we will give a true value, and then we'll come out the addition, subtraction, multiplication, and the division result. So here we have to define two input symbol or variable. Okay, so remember later we have to create the class with two input variable. Okay, and then here I will create a file output. So first one is the sum result. Second is the subtract result. Then the multiplied result, the divided result. But here I just want to highlight that actually we have some command that can restrict the data size. Because as you know, normally we use word A multiply word B, then we will get double word data, correct? Right? But here we can use some command to limit the data size. So here we define two symbol as input, then another for with the output, and another output with a double word format. Okay, so what we have to do, this is inside the function block. We use the SM400. SM400 is actually equal to M1000 in DBP PLC, means always on. So here we use the input 1 at input 2, then we get the sum result. Then this is a subtract. So use input 1 subtract input 2, we get the subtract result. Then here you can see this is multiply 16. So then that's the reason why we can define the word, the result with word. Because this one we use 16, that means the result is within the result type is word. And here we also use the divided 16. So that's also the reason why here we can use the word. But if we use the standard one multiply, then it will become a double word. Okay, so here is the example. And then I will show you how to do this. Again, always remember, this is my personal habit, but up to you. I think for the first, you should check the PLC connection. Okay. After that, we create a new program. Sorry, we should create a new function block first. Okay, so if you still remember, we have to create two input. I think if you already install the ISP soft, you can also try to create the function block and the program and follow my my step. Then later you can test at your side. Okay, so we create the two input variable first, and then we create another for output with our data type word. So we here forgot to define to the correct one. So we move back and modify here to output. Okay, and then we will use the standard one. That will be the double word. Okay, if you want to change, you just change the data type. You just like place the word or bool. You just click the first item, first later. Okay, or you can just click here and select. Sorry. Okay, so we just write this, and we already finished the function, and then we can use this function block here. So you will see for this function block, we have 2 input and 5 output, and then you can define the one condition to enable. So maybe we call this one enable function block. And I think for easy, we just define a data register here. For example, the 100, the 102, and this one, the 200. But and here, if you remember, because this one we define in double word, so we just define any result, maybe called multi-result. So you will see here what define as a double word. But sure, you can define this in like a D208. Also can work. Okay, then we can download the program. But if you still remember now, is actually use the USB, but we connect with this PLC with Ethernet. So have to change this one to Ethernet. For Ethernet, the station address is not that important, so you can also keep in 0. And then we can download the program. Oh, sorry. This one I set the PLC ID. So with me, I have to reset this one to factory setting. Okay, so sorry, wait a moment, then we power off PLC and connect. Okay, so example, we give the 100 in the 100 and give the 20 in D102, and then we can give the enable. So you will see why no value because now PLC at the stop status. So this one is also very important because many people, when they first time use Delta, they will also face this issue. So once you switch to run, you have to fill in the value again. Okay, so you can see the result. And example, if we want to, we modify this one to the symbol name to the variable. Okay, so so here we define the input value value 1, and then we define input value 2. Okay, and this is the result 1, result 2, and result 3. Oh, sorry. Result 3 and result 4. Okay, and then we can click this one if we you still remember in the morning we talk about we can use the device monitor table. So we click this one. I think I will also mention about this function, so maybe I just do it now. So once we create the device monitor table here, we have several ways to add on the device, but the most simple one is you select the symbol, and because we just define here, so we just select all and apply. Okay, so we switch online. This one, okay, we back to here. This is weird. Why did not show any value and cannot control? Sorry. I think maybe I made a mistake. Okay. I don't know why it's become a global, so that's why we cannot change the status. So you can see that is, and now we change the value, input value to from 20 to 5. Okay, so you can see then we can get a different result. So this is the purpose for device monitor table. It will be more easier for you when you just want to monitor and or do the troubleshooting for some specific portion of the program. Not sure, do you have any questions so far? I think this is the, I think this purpose, this portion, I just want to let you know how to define the symbol and how you can create the function block by yourself. This is the most simple one, and definitely you can create a more advanced one. Okay, and for device monitor table, I think already finished. So this we already do this. And another way is you can just simply add on the device or click from here. So I will also show you. And another, you can change the data format because not all value will show in the decimal. Sometimes it will be a floating value or it will be ASCII word. So this one you can change from the radix. Okay. So let me back to the software. I mean, you can change from here. And another way to add on the device is you double click the empty space. Okay. And then example, you can put like the 131, sorry. Okay, so example, you can monitor like this, or we can go to the program. This one is fine, whether you define the variable in a function block. So if we select function block, then you can see we can select this. And again, if we select the program 0, means the program, the variable we define in local variable defined in program 0. So you will see that input value 1, which we already include on the top. Yeah. So this is the way that how we do the device monitor. So not sure any question regarding this portion. I mean, for simple and device monitor, this just a basic portion of the ISP SOP, but this I think quite useful, especially when you try to do the troubleshooting. Okay, and next I think will be the new function for AS and the ISP SOP. I think let me finish this page, this view page, then we take a break. Okay, so for AS and the ISP SOP, we add on the new function is so-called the position name plane table. This one actually you can find similar function from Mitsubishi. Okay. So this one is basically for the pulse chain or built-in pulse chain position. So you can define the different address like target position. For target position, you can define like a real position, or you can use the data register like here. So example, here we use the 20,000, D20,000, then this 20,002. But unfortunately, here we only support for the position like target speed, bias, acceleration, deceleration. For this one, we have to define with the constant value. We cannot define with the variable or data register. Okay, this is the first function, positioning a plane table. So we can define maximum 200 points, 200 position for 6 axes for most of the model. Okay, and then will be the data tracer and data logger. So you can see the difference. This is a data tracer, and this is for data logger. What we can recall maximum is 20 watts or 20 bits, means 20 board device. Okay, and this one is also new for the Ethernet IP. So maximum can support up to 500, that means 250 watts. And then for the can open motion control. So for ACE, we can use the can open to control at axis servo drive and at axis VSD. Okay, so you can see from more clear from this page. So again, let me move back. This position plane table is used for, is based on the pulse chain control. Okay, so different model, we will have a different pulse chain axis. Mostly will be 6 axis, but X218, this one can support only 3 axis. But so that means if you want to use the position plane table, then you still have a 200 point, but this is divided by 3. For the rest model, you have to use a 200 point divided by this 6 axis. Okay, so this portion is for the pulse chain control. And for AS300, you have to add on. You have to purchase another extra can open function card, but for AS200 or 100 is built-in, so you can use this function to control another at servo drive and another at VSD. And besides, you can also add on 7 AS remote I/O station. So I think the most important, if you want to use the can open, is you have to do the communication initialization. So you have to use this one. Then this one is ASD on. I think if you ever use a Delta servo, then you will know what is ASD. ASD means our servo. Okay. So because at beginning only support servo, so that's the reason why the command called ASD on. Okay. But like an inverter, you also use ASD on. Okay. And for rest function, I believe if you ever use a Delta PLC or DVP PLC before, then you will know what is this. Like in DVP PLC, we use the POSV, that means for speed control. So the same in AS PLC. And then we have the so-called homing. In DVP, we also call ZRN. ZRN means zero return. So C means for can open. And we also have the DDR-VI or DDR-VA in DVP. So here we just add on C means can open. So DRVAC or DRVIC means the relative or absolute positioning. Then this one is same as we add on C in the end, like a PLS VC means can open speed control. Any question regarding these 2 pages? Okay, if not, then we move on to the multiple combination of A's. So here we have a 4 solution. So you can see basically we can use the Modbus or either Modbus TCP connect to the DOP100 HMI. And I believe some of you know that we have 2 SCADA system, one called DI-View, another is VT SCADA. So you can use either Modbus TCP or Ethernet IP. And this portion, I think we just mentioned, you can control up to 6 ASICs. And for the CANopen portion, add servo and add VSD and 7 remote I/O. So you can see this is the second solution. Okay, another pure solution is first solution A. If we don't want to use this servo drive, we just use for a remote I/O purpose. Then for CANopen, we can extend maximum 16 remote I/O. Okay, so this is the first solution based on CANopen. And you will see solution B. So if today you really need a lot of remote I/O, then we can use either we can use CANopen and Ethernet IP remote I/O at the same time. But if you still remember, in the morning I emphasize no matter you use local or remote, the maximum point is 1024 point, okay? And the module number is 32. So just remind you, even we can expand a lot, but still some limitation for the module and the remote and the point. So this is the solution B. We use CANopen and Ethernet IP remote I/O at the same time, so you will get a total 30 remote I/O. So the final solution is we use the S servo drive at BSD 7 S remote I/O and Ethernet IP at the same time. So we will get 22 remote I/O station. So that's all for this page. Not sure, do you have any question?